Hello friends, welcome back to my YouTube channel. This is Spandana of CC department studying at Sri Venkateswara College of Engineering. Today we are going to discuss a topic that comes under the subject Mathematical Foundation for Computing Probability and Statistics. Now let's get into the topic. Curve fitting by a method of least square method in the form of exponential. This is the topic that we are going to discuss today. Under this topic, let's see curve fitting by least square method definition and fitting the data in the form of exponential and problems related to it, and let's see application for this. Firstly, let's see curve fitting by least square method. Let's see a definition of it. Curve fitting using a least square method is a statistical technique used to find the best fitting curve to a given set of data points. Least square method, it is nothing but the process of finding the best fitting curve or a line of the best fit for a set of the data points by reducing the sum of the squares of the offsets of the point from the curve. During the process of finding the relation between the two variables, the trend of outcomes are estimated quantitatively. This process is termed as regression analysis. The method of the curve fitting is an approach to regression analysis. This method of fitting the equations which approximates the curve to a given raw data is the least squares. It is quite obvious that the fitting of the curve for a particular data set are not always unique. Thus, it requires to find a curve having a minimal deviation from all the measured data points. This is known as the best fitting curve and is found by using the least square method. Now, see a brief explanation. The least square method is a crucial statistical method that is practiced to find a regression line or a best fit line for a given pattern. This method is described by an equation with specific parameters. The method of the least square is a generally used in evaluation and regression. In regression analysis, this method is said to be a standard approach for approximation of the sets of the equations having more equations than the number of unknowns. Next one is the method of the least square actually defines the solution for minimization of the sum of the squares of deviations or the errors in the result of each equation. Find the formula for the sum of the squares of errors which help to find the variations in the observed data. The least square method is often applied in a data fitting. The best fit result is assumed to reduce the sum of the squared errors or residuals, which are stated to be the difference between the observed or experimental value and corresponding fitting value given in the method. There are two categories of the least square problems. The first one is ordinary or linear least square, and another one is non-linear least square. This depends upon the linearity or non-linearity of the residuals. The linear problems are often seen in regression analysis in statistics. On the other hand, the non-linear problems are generally used in iterative method of refinement in which the model is approximated to the linear one with each iterative. Now let's see a fitting a data in the form of exponential. Fitting a data in the form of an exponential function involves finding the curve that best represents the exponential relationship between the independent and dependent variables. The general form of an exponential function is y is equals to a into e to the power bx, where y is the dependent variable and x is the independent variable, and a is the coefficient that scales the exponential growth, and b is the rate of the growth. Now let's see steps to fit a data to an exponential function. The first one is create the exponential fit curve, that is plug the value of a and b into an exponential function y is equals to a into e to the power bx. This curve represents the best fit exponential function for your data. Plot and assess. Plot your origin data points along with the exponential curve on a graph to visually assess how well the curve fits the data. If the fit is good, the data points should closely follow the curve. Evaluate fit quality. You can also calculate the statistical measures like coefficient of determination, that is 2R2, to quality how well the exponential model fits your data. A higher 2R2 value indicates a better fit. Extrapolation. Be a caution when the extrapolating behind the range of your data. Exponential functions can produce dramatic changes for small shift in x. So extrapolation may be reliable. Now let's see one example problem. Calculate the fitting exponential equation, that is y is equals to a into e to the power bx, curve fitting using a least square method. Using this equation, we have to fit the data in the form of least square method. These are the x values and these are the y values that they are given. Now let's see a solution for it. That is, the curve to be fitted is y is equals to a into e to the power bx. Taking logarithm, we get log to the base 10 y is equals to log to the base 10 a plus bx log to the base 10 e. These are the values that we are going to get. Then y is equals to a plus bx. This is a normal formula. We are going to compare to this formula. So we are going to substitute now in place of y is equal y, we are going to substitute log to the base 10 y, and in place of e we are going to substitute log to the base 10 a, and in place of b we are going to substitute b log to the base 10 e, which is linear in y comma x. If it is in a linear form, we are going to we are having a normal equation, that is summation of y is equals to n into a plus b summation of x, and summation of x into y is equals to a summation of x plus b summation of xy. These are the normal equation in a linear form. We are going to find the unknowns to substitute in this formula by this table. That is, first we write x values and y values, and we are going to find y value by log to the base 10 y, and x square and x into y. For finding the y values, we substitute all the y values that they have given, and we find a summation of y, and x square we are going to square the values of x, and we are going to find the summation of x square, and x into y we are going to multiply x values and y values, and let's do a summation of x into y. So these are the required solutions for the substituting in normal equations. Now let's see a solution after substituting these values in a normal equation. That is, in first normal equation we get 6a plus 7.5b is equals to 3.81, and in second normal equation that we are going to get 7.5a plus 13.75b is equals to 10.4556. After solving these two equations using the elimination method, we get a is equals to minus 0.9916 and b is equals to 1.3013. And after taking anti-log of these values, and after getting the values, we are going to substitute in this equation, that is y is equals to a into e to the power bx. We get y value as 0.102 e to the power 2.9963 into x. This is the required value. Let's see application on this. Here's how you can apply the least square method to fit an exponential curve to your data. Collect the data, gather your data points, which should consist of pairs of x and y values. Transform the data. Linearize the exponential equation using a logarithmic transformation to make it amenable to linear regression. Take the natural logarithm on both the sides. That is, ln of y is equals to ln of a plus bx. Substitute in place of ln of y as y and ln of a as a. Then we get y is equals to a plus bx. Perform the linear regression. Now you have a linear equation in the form of y is equals to a plus bx, where y is the intercept and b is the slope. Use the standard linear regression technique to find the values of a and b that minimize the sum of the square root difference between the observed y value and the a plus bx values. Back transform. Once you have the values of a and b from the linear regression, you can determine value of a and b for the original exponential equation. That is, a is equals to e into a, b is equals to b. Evaluate the fit. Calculate the fitted y values using the original exponential equation. Y is equals to a into e to the power bx with the determined a and b. Compare these fitted values to the original y values to evaluate the goodness of the fit. Visualize. Plot the original data points along with the fitted exponential curve to visualize how well the curve fits the data. Thank you for watching this video.